Oke, assalamualaikum warahmatullahi wabarakatuh. Uh, I'm Wanda Kapunawal from Robotics at 7th semester, and in this time I will explain about genetic algorithm and differential evolution for robotics control flows. Okay, the first one is genetic algorithm. And what is genetic algorithm? Genetic algorithm is a method for solving constrained and unconstrained problems. Genetic algorithm, which based on natural selection, the mechanism that propels biological evolution, is a technique for solving both limited and unconstrained optimization issues. A population of unique solutions is repeatedly modified by the genetic algorithm. This method chooses members of the present population to serve as a parent at each stage and employs them to produce the offspring that will make up the following generation. The population evolves toward the best option for the course of subsequent generations. This method can be used to tackle a number of optimization problems, including those where the objective function is discontinuous, non-differentiable, stochastic, or highly nonlinear, and are not well suited for typical optimization algorithms. And as you can see, this is a flowchart from genetic algorithm. The first one is create initial population, score and scale population, then retain the elite, and select the parent and produce crossover and mutation children. And next one is to produce the next generation from the current population. There are two basic sort of rule at each stage. The first one is selection rules. Choose the people referred to as parent who contributed to population as the following generation are chosen. The second one is crossover rules combine two parents to generate children for the future generation. The third one is a mutation rule, apply random modification to specific parents to generate children. And this is how genetic algorithm works. The first one is an initial population created at random. Algorithm generates a series of fresh population. The algorithm builds the subsequent population at each stage using member of the current generation. The algorithm follows the steps to produce the new population. As you can see, there's a few steps. The first one is compute the fitness value of each member of the current population to determine the score. The raw fitness score referred to these numbers. Next is translate the raw fitness ratings into a more useful set of numbers by scaling them. Expectation values are the name given to the scaled values. Next is choose members referred to as parents according to their expectation. The elite are chosen from among some of less to fit members of the current population. The subsequent population inherit these outstanding individuals. Generated offspring from the parents. Crossover is the process of mixing the factor entries of two parents, while mutation is the process of producing random chains to single parent. And the last one is consists of children who will eventually replace the current population. And there is also a few steps. When the one halting requirement is satisfied, the algorithm terminates. There is a rule. The following options are used by genetic algorithm to decide when to halt or stop. The first one is max generation, or called as the algorithm stops when the number of generation reaches max generation. Second one is max time. The algorithm stops after running for amount of time in seconds equal to max time. Third one is fitness limit. The algorithm stops when the value of the fitness function for the best point in the current population is less than or equal to fitness limit. And there is a two occur for linear and integer limitation. The technique is used modified state. The algorithm alters the population evolution when a text involves integer or linear constraints, including boundaries. The software adjusts all generated individuals to be feasible with respect to the requirements when the problem involves both integer and linear constraints. With regard to integer and linear restriction, the entire population remains viable regardless of the creation, mutation, or crossover function used. The software does not change persons to be viable with respect to restriction when the problem merely has a linear constraint. Use a function for creation, mutation, and crossover that ensure linear constraint feasibility. Otherwise, the population might become impossible, which would make the outcome impossible. And the last one is nonlinear constraint requires further modification of the algorithm. And I will explain about differential evolution. And what is differential evolution? Differential evolution is a heuristic method for the global optimization of the nonlinear and non-differentiable continuous space function. We begin with a base population of potential solution by introducing mutation into the population and keeping the fittest candidate solution that produces a lower objective function value. These candidate solutions are iteratively improved. Different evolution can manage multidimensional objective functions that are nonlinear and non-differentiable, while only requiring a small number of control parameters to guide us to the minimization. The algorithm is simpler and more usable as a result of these features. And there is a minimization algorithm is supposed to meet four criteria before being deemed practical. The first one is capable of managing non-differentiable, nonlinear, and multimodal cost function. The second one is ability to parallelize to handle cost function with high computational demands. Simple to use with minimal variables to control the minimization. Good conversion qualities are the global minimum constant convergent in a successive independent trials. And this is how differential evolution works. An initial population of real value decision vectors, commonly referred as genomes or chromosomes, is randomly chosen to start the process. This stands in as a potential answer to the multidimensional optimization issue. The method inserts mutation into population during each iteration to produce fresh output potential answers. The weighted difference between two population vector is added to a third vector as a part of the mutation process to create a modified vector. During a process known as a crossover, which attempt to increase the variety of the perturbed parameter vectors, the parameters of modified vector are always more mixed with the parameters of another first vector. The target vector, the trial vector, is the resulting vector. Okay, that's all for me. Thank you. Wassalamualaikum warahmatullahi wabarakatuh.